Hello everyone, welcome back to AWS Launchpad. We're here from the London Summit talking now about mobile application development and some new features and services that we have for that. I'm joined today by Daniel and Anupan, and I will start by asking you to tell our fellow streamers what you do for Amazon.
Sure. Hi, my name is Daniel. I work as a solutions architect at AWS out of our Berlin office, where I help customers and startups especially use AWS and optimize their services. And I also help customers with mobile services all over Europe.
Cool. I'm also a solution architect. I work with startups focused in London. And a lot of work which I do is thinking about how startups are building their software and what are the lessons they can learn from a lot of other startups which are building similar systems. So looking forward to sharing some of the lessons we have learned in mobile space.
So, in this mobile space and developing mobile applications, I'm a developer myself. I hear that GraphQL is the new order and what everybody's using to build it. Could we talk about what is GraphQL and why does it matter?
Sure. GraphQL is a query language for APIs. It's an open standard. And basically, it enables clients to load, to change, and to subscribe to data from servers. When you build mobile apps, there's some common challenges. Web apps have those too, and GraphQL tries to address those. Those are things like the data requirements, they change over time. You need different data for different platforms. You have relationships between data. You have lists with reduced information that comes back from APIs. You have ordering and pagination. You have notifications. So those are all common challenges. And with GraphQL, those are all addressed. So with GraphQL, the client specifies the format and the structure of how the data that needs to be retrieved, what it should look like in the query. And so when the client loads the data, they load only what they need and only in the format that they need. And that's basically what GraphQL is.
Cool, and what are we doing about it? How does that relate to Amazon?
Well, absolutely. We have released a service called AppSync. And AWS AppSync is a managed GraphQL service. It's part of the AWS mobile services. It's a serverless service, so that means there is no servers for customers to manage, to set up. AppSync helps customers to rapidly prototype and develop GraphQL APIs. And you can use it to build real-time data access and update applications. So for example, if you have collaborative mobile or web applications, AppSync is the service you'd use to help build those.
So if I understand correctly, this is for the client-side developer, for your mobile web app to synchronize data and get all the hard part about synchronizing it to the cloud and storing this data somewhere, and separate this from the mobile app developer so that he can focus on building a better experience.
Right, well actually it's on the back end, it's usually what you have with RESTful APIs, for example, there's some sort of a coupling of what the API looks like on the back end, and then on the client side, you just have to work with what you're given by the back end, by the API.
And now, you mentioned a specific thing there that's very interesting. How this compares to REST? Like, what's the comparison, and how is GraphQL different from REST APIs?
Well, you've got the basically the REST has those challenges that I mentioned, where you have the different URLs for different objects, and you have the lists that contain maybe the data you have, but maybe some other RESTful URL contains other data that you have. And with GraphQL, you specify in your query what are the elements that you want to retrieve.
I see. So for example, I know in many systems, especially with object relational mapping, you get a lot of data back. So in GraphQL, you can say, hey, I just want first name, last name, and age, and that's it, and it will bring back just that.
That's exactly right. So you just use it, you connect to the endpoint, and you discover what the data looks like without a knowledge of the backend. And exactly like you say, in your query, you specify, here's the object that I want, that's the fields within that object that I want, or those are the relationships I'm interested in, and whatever you're not interested in, you don't put that in your query, and then it doesn't come across. And so,
yeah, essentially, I think the client has the full knowledge of what data resides in the server, and server sends whatever is needed to the client without client making multiple requests for the same data.
Exactly, one query per view, basically.
Yeah. So there's a lot of things that's possible on this mobile space, and especially with GraphQL. Could we just make a clear statement of the main features of AppSync?
Yeah.
So to understand, like, what's the key points they should remember?
So AppSync is a simple, scalable, real-time synchronization service that enables you to do queries, filtering, and search inside your applications.
Filtering and search.
Yeah, query, filtering, and search in your applications. You use AppSync to connect to resources in your AWS account.
Okay, perfect.
It has built-in offline support. So
how you define this? Like, how do you bind this to your data sources? How you define those schemas? How does this gets built?
Yeah, so basically in AppSync, when you start with a project, the first thing you do is you define a schema.
Okay.
And the schema is defined in a schema definition language.
Okay.
And it basically has three operator types. It has a query for read, it has a mutation for writes, and it has a subscription for if data changes and you get pushed back in real time. So when you define your schema, you define these three root types. They're always part of that.
I see. Could we take a look at it and see what it looks like when building it?
Absolutely.
Let's switch to your desktop then.
Yeah. Is this good? All right, so this is the AWS console that everyone knows from when you log into AWS on the web browser. So here we'll just type AppSync.
Can we maximize and make this just a little bigger?
Sure.
Awesome.
Let's make this bigger.
Easier.
Is this good? Okay, perfect. So look for the AppSync service. Open it. All right, so that's actually, I've got some APIs here already, so let me show you what it looks like when you're on first run. I'm going to Ohio because I don't have any APIs defined here. So that's your first run experience, where you'd click Create API. For the demo, I'm going to show you guys what it looks like in Ireland, though. So I'll go back to there. So you see, it just looks a little bit different when you've used it once in a region. So you create an API here, and first step when you create an API in AppSync is you have to name it, right? That's one of the three difficult questions in IT is naming things. So let's just stick with the default.
So what API are you going to create today?
So you have a choice between doing a custom schema right here or doing a sample. And I think for simplicity's sake, we'll just stick with the sample. What the sample does is it creates events with comments on it. And it saves those to a DynamoDB table.
So you can assume an app where users are interacting with your content and they're commenting on how the content is.
Exactly, so it's like a calendaring system where you post an event and then other people can post their events or comment or change events.
Nice.
Yeah, that's what this sample is. So you see the details of what the event schema looks like. And in the schema, if you scroll to the very bottom, there you see the three root elements that I talked about. So you have the query, which maps to query. That's those we see here. You have a mutation, which maps to mutation type up here. And then you have the subscription root element, which maps to subscriptions here. And then within each of these, you get you have your queries here. So within the query, you have the get event query, for example, which has an ID attribute, which is of the type ID, and the exclamation mark means it's mandatory, and the return value of that is an event type.
I see.
So every API which you design will have this structure. They will always have a schema. They will always have a get query.
It'll always have the schema, and what happens after that is up to you. So the only other thing I guess you always have is that you have types, and then everything flows from the type. So if we look at event, for example, I'm going to show you where that comes from. And let's stay with the query for a second. So we also have list event. I'm not going to go into all those details again because it's similar. Yeah.
There's one detail that's really important there. Does this mean that I don't have to write pagination code on server side anymore? It will just come paginated for me?
On the client side, yes, because of what's happening behind this. So we'll actually look at the details of how this is implemented.
So cool.
Yeah, I'll show you. Okay, so we've got event defined here as a result, as a return type of get event, and event connection returned as a result of list events. And event connection, the naming is with connection. That's kind of the that's been established as the standard in GraphQL for paginated results.
I see.
Okay, and now we'll look at where event connection and event are actually defined. So we see type event connection is up here, which contains items, which contains an array of events, and the next token, which is a string. And the type event, which we've seen here and which we've seen in the queries, is defined up here. So that's one of our application objects, where you have an ID, a name, field, where the event takes place, when it takes place, the description of the event, and then the list of comments, which, and you see again here, comment connection, that's a paginated list of comments. It's defined up here.
So you have individual data types and you have collection data types, which are covering those individual data types, right?
That's right, yeah. But basically it all gets defined in here, in your schema.
So it does not have anything to do with my database schema. This is a client-side schema,
That's a good point.
say.
Yes, absolutely. The mapping from the GraphQL schema to what you have in your database that's completely separate. So the piece that's between those is resolvers. We can take a look at those next, actually.
Sure, let's do that.
All right, so we haven't created this API yet. We just went through the sample. I'll click create now, and now what AppSync does is provisions that API on the back end. There's a number of example projects here. We'll pick web for the demo that we'll do later on. So you copy this git command to clone the repo and download the appsync.js config file. That's important because that tells the client how to connect to your schema. But that's also pretty much all there is.
Okay.
So is the schema also downloaded along with it, or schema is...
This is actually just the configuration.
Yep.
If you have a local IDE that has code completion, you can download the GraphQL schema from here as well.
Is there anything the developers need to do with this JS config file, or just save and go?
You'll drop it in your project. So we'll do that in a second when we look at the application.
Okay.
So it seems like there were some network issues. Shall we summarize what we have talked so far? So sorry, I think there was some interruption. Can we summarize what have we discussed so far in this application, so,
all right. So
people who are just joining in can understand?
Sure. So we've looked at the schema of how the schema is defined. We have a sample project that has events and comments on events. And now we've just created the API and downloaded the config file that AppSync generated for us that relates to this API. What we're doing next is, well, I guess we could look into how the application actually works.
Sure, yeah.
Should we do that? Okay, make this big.
So what all you have on your machine right now? So you have a JS file, JavaScript file which you downloaded.
Yep.
And then you have a schema file which you downloaded.
I didn't download the schema file, so it's just the .js, the config.
Okay.
And I copied the git clone command, and I'll paste that in here now. So I just prepared the path before, and that's it. Okay, now git cloned it. Actually, I have to look
So you cloned which repository?
I cloned the starter, the starter project, basically, from GitHub, the example that comes with this sample GraphQL.
Can you show our viewers where they can download that?
Sure, let's go back to, where did we have it? Here. So it's after you create the API, which was the sample that we had here, you clone the repo right here.
Yep, so they can just copy-paste this.
That's exactly what I did. I just clicked on the copy button, and then pasted it from my clipboard in here. So now we see the project got cloned. Now I move into the project directory, and I just copied from my notes the move command, so I don't have to type it. So we're moving the appsync.js to the source directory that's inside this clone project. So we see that here.
Yep.
Source, and that's what it did now. It moved appsync.js to source. And now the next step is configure it with Yarn, get all the dependencies.
What is Yarn doing here?
Mm-hmm.
So Yarn is loading the description of the project and installs all the dependencies that the project needs.
Okay, and while it does this, we have a couple questions about related technologies. I know we can't discuss competitors, but is there anything you could say about the relation between GraphQL and OData and Firebase and these other technologies that are perhaps in the same space?
Yeah, so I think there are various choices when you have to build mobile apps. It could be you having all the client-side code on mobile applications and making API calls to server. The second option is you use something like GraphQL, and I think there are different providers which provide similar functionalities. Actually, GraphQL was built by Facebook, and it's an open source thing which a lot of companies are using these days.
Cool. So let's see the app running.
Yeah, so that the sample app has started. It opens the web browser, and now what we do here is just create an event. Let's call it Hello London. It's happening right now at the AWS Summit in London.
So you're simulating a user writing this. There's a user writing a comment on a website.
Some user is using a website now or an application and feeds it with data.
That's interesting. So it can be either a mobile app or a web app. It's not restricted to one or another, right?
Exactly, yeah. So it's anything, so this example that we're doing here is anything that's JavaScript based.
Cool,
But,
and what happens behind the scenes there?
All right, so what it did now is it submitted the mutation request to create the event. Actually, it's easier if I show you on the console how it flows through the schema. All right, so we've got we've had the mutation, create event, and we see here the mapping of the fields on the background of the web app. Those were the properties that I entered.
Okay.
Up to description, and so what the app did then, it called this mutation the create event mutation, and what happens next is that's where we look into the resolver function. So I'm looking here for the mutation create event.
Okay.
That maps, actually it lists the name of the data source, which is a DynamoDB table in this case, based on the sample that we're looking at. But actually when you tap on it, it opens the resolver function for this mutation call.
So instead of writing my data access objects and things like this, I can just use the templates and the mutators that...
Exactly, pass in your JSON object and let the resolver do the rest. And what the resolver does in this case is you configure the data source name. That's our AppSync event table. This list is populated from the data sources that are configured for this API. And you configure request mapping template, so that means when new data comes in based on the call. There's a number of samples as well, and in this case, the code is already built. So this is a call to DynamoDB, a put item operation, where the key, actually people who use DynamoDB, they'll be familiar with this notation. The key, a string,
yep.
And the key here, we're using a utility, a helper utility on the AppSync side, which automatically generates UUIDs, which we use for IDs here in this case. And then the attribute values here, you see we're just mapping from a context object, which is always part of a resolver call.
Okay.
Which has been called with arguments.
I see.
And the arguments contain the name. So that is what we saw mapped in the schema earlier. And that names to the name property in DynamoDB. And that's kind of how they all work.
And if instead of a DynamoDB, could it be a relational database, for example?
Could it be a relational? I think you could make it work with a Lambda function. So as data sources, you have a number of options. You can use DynamoDB as a table, as a data source. You could use an Elasticsearch domain. You can use a Lambda function also.
And from a Lambda function, you can go anywhere.
You could call RDS, for example, for a relational database system. Awesome. The challenge, you could call an external data source, like if you have another API you want to call for some reason. The challenge here, something you have to watch for is, because AppSync is a managed service that's serverless, it can scale very rapidly, depending on what your users do. And so the challenge is you got to make sure to protect your backend too, not that you
totally. I know Dynamo can scale infinitely, but not APIs are like that, right?
Yeah.
Totally.
Yeah. There's a question, can you have a REST endpoint as a data source for a resolver? So maybe they have a REST service already running and have this as a front end to that REST service.
That's exactly that example, right? Where you have a Lambda function that would pick up your details and then pass it on to another external
And on the calling side, it will again pull it from a Lambda function, which is pulling another API which already exists. REST API. Yep.
So we have a question about scaling. So this is serverless. I don't need to scale it myself. But I do need to take care of the scaling of the backend just to make sure people get as we're talking that scaling AppSync itself, it's not necessary, but on the backend you have to make sure your data sources will handle the load, right?
That's right. If you use DynamoDB tables, for example, you don't have to do that though, right? Okay. Because in DynamoDB you can enable automatic scaling of read throughput, write throughput. It goes into millions of requests a second or more. You can automatically enable that the service can automatically scale the provision throughput for your table. And that way, if you write to Dynamo, you actually don't have to worry about scaling anything ever.
Perfect.
Or Lambda is the same way, right?
Is there? You were going somewhere. I interrupted you there. Is there anything you'd like to show on this demo?
We were looking at the. Well, it's maybe we don't have to show it. Just on the resolver side, when you pass in the object to be persisted in a data source in the resolver, we saw the request mapping template, which is written in Apache Velocity. So if people are familiar with Velocity templates, or really Java as a language, people know that. So it's VTL. On the response side, you also have a mapping. So we didn't show that, but it's not,
so you can change the response.
It works the same way.
So you can tweak the structure of the request and response on the fly.
I have a very interesting question from Delora. How does it work, the sync part of it? Do I have to worry what happens when the synchronization happens between AppSync and my mobile app? Do I need to worry about conflict resolution and this kind of things, or it's totally transparent?
It's a good point. Thanks to Lotta for asking that. That's actually one of the features of AppSync is that on the client side, the synchronization is completely transparent for you as a developer. You use the SDK that AppSync provides. So for example, if you use React Native or React or Web, you would use a project called AWS Amplify that can help you build that. And AppSync has, so in AppSync, when you do a fetch, when you do a query to load your data, the data is cached locally. And that's one of the points I was mentioning as a pain point for app developers today, is your customers, your users, they expect your app to work offline too. And that's where AppSync helps, because it caches the data automatically, and when you edit it offline, AppSync detects when you come back online and sends the changes out back to the service. And on the service side, on AppSync, you actually can configure server-side conflict resolution. There is 3 basic patterns that it supports. So you have that the server wins, whatever's on the server is the truth, or you can do a silent drop. You could also, if you have custom business logic that you need to implement to resolve conflicts, you could use an AWS Lambda function to implement that custom business logic. I said those were 3 options. The 4th one is you could do a callback call to the client side to let them know that there's a conflict, and that's typically the only option that you have with most systems, but AppSync provides you server side, that on the server side.
Yeah, I think this is excellent for users who are traveling, like going in a tube where there's no
Yeah,
network
or the
connectivity,
airplane, yeah.
or going somewhere where they don't have connection. So they just use your app, and all the data is cached, and they can interact with the app as if it's still connected.
Exactly, and that's kind of what users expect from apps, right?
Yeah.
Great. We're getting near to the end. Would you have any suggestions for people to get started? How can they go on and build their apps with AppSync?
Yeah, absolutely. So I mentioned AWS Amplify. That's a tool that makes it really easy to get started with AWS mobile services in general. Maybe the best recommendation I have is just go try it out. It takes minutes to set this up. I mean, we've seen the app, a working app here. I don't know how long does that take.
Probably 5 minutes.
5 minutes. And every service we looked at here has a free tier, so it doesn't cost you anything. Beyond the free tier, you only pay for what you use. So my tip is go and build something.
Awesome. And that's the time we had for today. Get in touch with us. We'd love to hear more questions and get back to you with software development on AWS and help you guys be successful. Thank you very much for watching. Thank you, Daniel. Thank you, Nupan. See you in the next session.
Thank you. Go build.